So page 2 at the top. So really, with that one, it says to graph the function. Really, I should have said to do it without your calculator. That's why I wanted you to write a sentence explaining your choice, because you don't need your calculator for this, right? So you have everything that you need in the polynomial function. Okay, so if you're doing this without a calc, then when you're graphing the function, all you have to look at is the degree. Okay, and the degree is odd, which means what? Exactly. Okay, so the degree is odd. This is the explanation. Thus, the ends go in opposite directions. So what could I get rid of just because of that first thing? Which one of the choices? Yeah, okay, so A, go in the same direction, so that's gone. Okay, the next thing I can look at is the leading coefficient, right? So if the leading coefficient in this case would be 1, which is positive, since the leading coefficient is positive, what does that mean? Good, so since the LCO is positive, the graph rises on the right. And then can I eliminate another graph? Which one? All right, C is gone. See you later, C. And now, the very last thing, just use your y-intercept. What's your y-intercept? -8. Okay? Okay, so the y-intercept is 0, -8. So it has to be choice D, which crosses at -8. It cannot be B because the y-intercept is 0. Okay, so that's all I need. Bada bing, bada boom there. All right, now the next one, it says, which of the following could be true about the polynomial graph below? Okay, and then we're going to just write a brief reason for each, whether it is true or not. So before we go through that list, let's first just say some things that we already know about this graph. What do we know? Yep, there's one local minima right here. Okay, good. How do we know the degree is even? Okay, good. So the degree is even because they're going in the same direction here. They're both going down. What else do we know? Okay, how do we know that? Good. So the leading coefficient is negative because it's going down on the right. And then Ava said there was a local minima. There's also 2 local maxima, which means how many turning points do I have? Okay, so if I have 3 turning points, right, 2 local max, 1 local min, what does that lead to? Okay, so if I have 3 turning points, I know that the degree is 4. If the degree is 4, what's something else I know? Yep. What is that called? If the degree is 4, there's 4 zeros. Yeah, good. Fundamental theorem of algebra. Okay, awesome. All right, so we're going to use this to help us go through each one of these. And some of these are kind of tricky, so let's see how we do. All right. The degree is odd. Nope. Okay, if it was odd, the ends go opposite, and that doesn't happen here. Degree is odd, ends go opposite. Nope, not going to happen. All right, the leading coefficient is negative. Yep. Okay, That's all you need. Okay, that's the brief reason. My x means no. P of x has 4 zeros. So P of x is the polynomial. Does it have 4 zeros? Yeah, it has 4 zeros because degree is 4 because of the 3 turning points. And that means there are 4 zeros. All right, the degree is 3. That true? Nope. We know the degree has to be even. Even degree. Ends go in the same direction. Okay, the degree is negative. Could that be true? No. Can you have a negative degree? No. Remember we made the list 0, 1, 2, 3, 4, 5. Okay, the degree will not be negative. Degree will never be negative. Remember, what do we talk about in terms of whether it's negative or positive? The leading coefficient. Yes, great. Okay, so there are 2 real zeros. What do we think? Yeah, how do we know? Yeah, so there are 2 real zeros because there are 2 x-intercepts. That's true. Not only could it be true, it is true. Okay, P of x has 1 local minima. Is that true? Or could it be true? Yes. I'm fine with just the arrow there. Right? It has 1 local minima. There are 2 imaginary zeros. Yeah, it has to be true, right? Because if you have a total of 4 zeros, 4 total zeros, how many are real? 2. If there's 2 real, okay, then the other 2 have to be imaginary. Yep, so that absolutely could be true. What if it said 3 imaginary zeros? Could that be true? You can never have an odd amount of imaginary zeros, no matter what the situation. Remember, they come in pairs. And then also we know the number of zeros. All right, the leading coefficient is even. Could be, right? Is there anything that tells us whether the leading coefficient is even or odd? No. Okay, so nothing to confirm or deny if the LCO is even or odd. Okay, so the only thing that we worry about in terms of the leading coefficient is if it's positive or negative. Okay, it could be a positive even number or it could be a positive odd number. We don't know. Okay, so that one could be true. Okay, and then for J, P of x has 3 local maxima. Could that be true? Well, how many local maxima does it have? We can actually see that, right? Okay, so it has 3 local maxima. Nope, it has 2 local maxima and 1 local minima. All right, questions for me on that one? Mm-hmm.
Wait, why would the degree one is like you have to change?
Yeah, so that's our rule that we were just looking at on the first page. So anytime you have a graph, well, the turning points are 1 less. So with the degree of 4, you're going to have 1, 2, 3 turning points. With the degree of 3, you'll have 2 turning points. Yeah. And then number 9, I'm going to show you guys the answers to those. You can check your stuff. All right, so for the first one, when you're doing the reflection across the y-axis, you do have to plug in. I'm going to show you A and B together. Okay, so this is your number 9. Okay, when you're doing the reflection across the y-axis, you're going to plug in the negative x. So I put my work up here. negative x to the fourth, to negative x squared, negative 7 times negative x plus 10. Any place you see an x, you replace that. Okay, then when you're simplifying, negative x to the fourth is actually going to be positive x to the fourth because a negative to an even is a positive. And then same thing happens here. A negative times a negative, in this case will be positive, plus 10. Okay, and that's a reflection across the y-axis. Okay, so something that you might want to write on your note card are those function rules. Okay, do you know that if it's a reflection across the y that you're plugging it inside? Is all you need to put f of negative x is the reflection across the y, or do you need a full example? Okay, you decide what you need assistance on. Customize your note card. For B, it's a reflection across the x-axis, so that negative is on the outside. If it's on the outside, all you have to do is distribute the negative to every single term. So a negative times a negative is going to be a positive. Here, this becomes negative, this becomes positive, and this becomes negative. Questions for me on A and B? A and B, the reflections? Okay, yep.
Okay, so for A, why wouldn't it be just like 3 to the 4?
So because it's a negative 3 here, when you do negative x to the fourth power, what that means is you are multiplying that negative x 4 times. So it's negative x, negative x, negative x, negative x. So what happens is you end up, a negative times a negative is a positive, times negative times a negative is a positive. So this is positive x to the fourth, and then that gets multiplied by the negative 3. And so that's why that one turns out negative. Now, in some of these cases, you'll see like we have an odd one, and when you have an odd, so that's how I always do it. I do inside first, and then I do the multiplication. Okay, and then for C, it's negative 2 times f of x, so you're going to distribute. This is both a reflection across the x-axis and a vertical stretch by a factor of 2. You didn't have to write that in. I'm just reinforcing our rules here. And then when you distribute the negative 2, you're just distributing to each one of these. So negative 2 times negative 3 is positive 6. So 6x to the fourth. Negative times a negative is, or a negative times a positive is going to be a negative. Negative 2 times negative 7, that's going to be positive. And then negative 2 times positive 10 will be negative. So you absolutely have to watch your signs for that. Okay, and then D, you have f of 2x. So you have to substitute that any place you see an x. So it's negative 3, 2x to the fourth, plus 2, 2x squared, minus 7 times 2x, plus 10. And then because you have this plus 2 on the end, that vertical shift, you can just add that plus 2 right to the end. Okay, now this is your final answer. I want you to double check this. See if you accidentally put negative 6. See, some of you have the negative 6 and positive 4 here. Okay, so if you do have negative 6, this is the step you forgot. You have to do 2 to the fourth as well as x to the fourth. So you can see I do this in 2 steps. So I do my 2 to the fourth first to rewrite it as 16x to the fourth. And I'll do 2x squared to get my 4x squared. Okay, and then I'll multiply. Negative 3 times 16 is negative 48. 2 times 4 is where we get the 8. And then you have negative 14x. And then you're going to combine your like terms to get the plus 12. Okay, so that is a good one to practice. That one can be kind of tricky. All right, and then flip it over to the next page. So as I was checking through some of these, I noticed some of us did not simplify. So I want you to carefully check this.